All right, let's take a look at some examples from the research literature and also using R. In this example, we're going to look at a study called Of Warrior Chiefs and Indian Princesses, the Psychological Consequences of American Indian Mascots. Lead author on this is Stephanie Freiberg. Steph is a professor of American Indian Studies at the University of Washington. I take that back. That's actually not. She recently moved to the University of Michigan. Her website reads, she's a proud member of the Tulalip tribe and centers her research on how social representations of race, culture, social class influence the development of self, psychological well-being, and educational attainment. Incidentally, Steph is, her work was recently featured, recently appeared in Personality and Social Psych, one of the journals with all the S's and the P's, Social and Personality Psych Science. And this was the work focused on the Washington football team's name and how it was viewed as extremely offensive to the Native community through a very, very, very large, well-documented survey project that ultimately led the team to change its name. I know Steph because she's the president of the Society for Personality and Social, the Society for the Psychological Study of Social Issues, where I serve on the board with her, and she's a brilliant scholar. Other people on the project: Hazel Rose Marcus, Davis Brack Professor in Behavioral Sciences at Stanford University. One indicator that somebody is really, really big time is that they have a name before the professor. They have an endowed professorship. I believe Stephanie has one at Michigan now. Marcus focuses on how cultures, including how culture shape thoughts, feelings, and actions. So again, another superstar. Daphne Oyserman, another superstar, focuses on small changes in context, how it shifts mindsets. She's she's at USC, University of Southern California, and I also thought it was humorous that she's the recipient of the Humboldt Scientific Contribution Prize of the German Alexander von Humboldt Foundation. So somewhat of a Humboldt link for us. So some real superstars on this paper. And I have no idea who the fourth author is. They have it's like John Stone or some name like that. So I couldn't really find them. All right, so what was the study? Well, it was conducted with American Indian high school students, and it presented participants with one of 4 different conditions. Pictures of Chief Wahoo, I'll talk about who that is in a second. Pictures of Pocahontas from the Disney movie. I'm sure most of you know who that is. I don't want to say it too loudly or my daughters will immediately turn that on. A little cringy, but that's they were presented, the third condition, participants were presented stereotypically negative information, and what they were told is 50% to 55% of American Indian high school students actually drop out of high school. And then the fourth was a control group, which received a neutral message. They measured their academic self-esteem after exposure to these pieces. This is Chief Wahoo. He is the mascot of the Atlanta Braves. And here is, of course, Pocahontas, who is famous from Disney movies. Some other stuff too, but I don't know history very well. It's in a history class. Just to show you, Chief Wahoo, god damn, used to be so much more offensive. Not that I'm saying that this isn't offensive, but just to see what professional sports teams could get away with and newspapers saw as acceptable is just I mean, and this is the 20th century, is quite jarring. Anyway, so let's take a look at the analyses. How do we run an ANOVA? Pretty straightforward. It's the command is AOV, and then this basic formulation: data set, $, name of the dependent variable, tilde, data set, $, grouping variable or factor. I put these into an object called XX. The reason why that is that you get better information when you save this, and then you can use it in other analyses. For example, I summarized this, and it's giving me my F values, different sums of squares and mean squares and degrees of freedom. You can see the probability is 0.025, so below that 0.05 level. I can get an eta squared value, and you can see that eta squared value here gives us a value of 0.06, so about 6% of the variability in self-esteem could be explained simply by the images, by what they were exposed to. And then these two t-apply commands, these are going to be useful for assessing mean values and standard deviations, and we could do this with variances as well. One thing that we can see from these means, looks like Chief Wahoo and Pocahontas produced the lowest self-esteem compared to the other groups. Which groups differ from each other and which don't? Well, we don't know yet. So that's where our multiple comparison tests come in. So conclusion here, again, reject the null hypothesis. We know there's, but keep in mind when we reject the null hypothesis, this is sometimes called an omnibus null hypothesis. What does that mean? It means an overall null hypothesis. Overall, we're saying that somewhere there's a difference between two of those four means. We're not saying where it is, though. I would say it's a pretty good hint, though, that if two of the means are the same, that they're going to both be different from one of the other means. So what groups actually differed? Since the authors included a control group, probably the most appropriate test here would be Dunnett's. So that'd be a good pick here. And you can see this gives us all of the comparisons against the control. There's a couple of different ways to do these. I used to do this using a different package. However, I found in the Desk Tools package, setting the comparison group is very easy. I think in other packages, you can only choose first or last group. So it's nice here that we can say, okay, the control group is what's set as control is the actual control group here. So we could specify any group in that way, which is nice. We can see Chief Wahoo and Pocahontas do differ from the control group, meaning that they produce worse self-esteem than the control group did. However, the negative stereotypes on their own did not do so. If we had done this with a Tukey test, one thing that we can see is that we would get all 6 possible comparisons. And you can see how those laid out. The same ones are still significant. It might be useful to compare those 2 tests, though. If we compare the 2 tests, we'll see that Dunnett's test produces smaller probabilities than Tukey test. And the reason for that is when you're using fewer tests, you can be more liberal. When you have more tests, you have to be more conservative. And again, liberal conservative means in terms of how much ability you have to reject the null hypothesis, not whether you think like Mitch McConnell's an idiot or not. All right, graphing the relationship. I won't go too into the code here, but that's probably something that's going to be better for you to deal with in the tutorial. But just to tell you what we're doing here, the first part of this, I'm just calculating means and standard deviations and getting the sample size for each of the groups. And then I apply a formula within ggplot to calculate the confidence intervals. The confidence intervals are what's represented by those error bars. So these are 95% confidence intervals. Again, this code might look complicated, but anytime you see code that looks complicated, really all you need to do as a strategy is to copy and paste the code and replace the different variable names with your variable name, replace the data set with your data set name, and you'll be fine. All right, if I wanted to do orthogonal contrast, they might look something like this. We could ask 3 questions here. I don't know that this lends itself perfectly to orthogonal contrast, but certainly we could apply them. First question would be, did the mascots differ from the other conditions? And you can see we code that as 1s on the 2 mascot, well, Pocahontas isn't a mascot, but let's just say 1s on the 2 mascots, -1s on the other groups. Did the mascots differ from each other, and do negative and control differ? And you can see the 1, -1, and then the 0s for the groups that are not involved in those comparisons. Again, this should always sum to 0 across the way. And you might note that as long as the positive or negative are balanced, you can use any number you want in here. It all will produce the same values. A lot of people do this with decimals for some reason. I like 1s and 2s. And you can see what this looks like. Mascots versus others is significant, whereas the other comparisons were not. Ooh, Bayes factor. Just like with the independent samples t-test, we can also calculate a Bayes factor. And I'm increasingly seeing people reporting Bayes factors along with more traditional statistics. You've got your effect size, your probability, all of that stuff, and then people are throwing in Bayes factors there as more evidence for the strength of the relationship. I think that's a really good idea. Here the Bayes factor is about 1.5. Well, what does that tell us? Well, if you remember that scale that we looked at, Bayes factors that go from 1 to 3 are simply noted as anecdotal evidence. What is this telling us? Well, yeah, we had a statistically significant result with whatever the effect size was. However, the Bayes factor is saying, hey, the probability that the alternative is true over the null is not. There's not particularly strong evidence for that. It's just a 1.5 times more likely. So again, this does give some context. Yeah, we can reject the null hypothesis, but well, not really particularly strong evidence.